Here we go. So, solving rational inequalities. There's a couple of different forms of this problem. The easier ones are these that are basically a fraction with respect to 0. You're comparing it to 0. Huh? It's underneath the rational decomposing. Right? Right. Keep going. Right, and then there it is. Good. Okay. All right. So the whole idea is these are inequalities, right? So there's not one right answer, which is, or one or two right answers, which we did on the board where we actually solved. These are a string of answers or intervals of answers that we are going to look at to make this a true statement. What makes this nice is that this inequality less than 0, which means negative in this problem. We're looking at negative answers. Okay, so you got to really look at what the problem is asking. To help us find our intervals, the first thing that we want to do is figure out, again, what x can't equal. And where do we look to figure out what x can't equal? Our denominator. So if if our denominator is not factored, we have to factor it. In this case, we know that x can't equal what? Okay, so we create an interval, and I'll show you what I'm talking about. Notice that x can't equal. Okay, x cannot equal those. And so when we talk about inequalities and we talk about graphing these values, right? When we cannot equal something, what kind of what do we put on our number line to indicate that it can't equal that, but that we want to start there? An open circle, right? Versus a solid circle right at that value. You know what I'm talking about? Mm-hmm. So, for example, we're at, here's 0, 1, 2, 3, 4. 1, 2, 3, 4. So currently, we're looking at these places on our number line, all right, but we are not allowed to ever use 3 or 4. Okay? All right. The fact that I have strictly an inequality means when I go through and now solve, the solutions that I get also will be just open intervals too. If I had an equality in this problem, when I would solve, I would use a solid dot because it could be that value or something else. Are you following me? Okay. So be very careful. This is also going to be open intervals. Finding your zeros can be either open or closed intervals, closed values, depending on what the original inequality in the problem is. Are we okay with this? We're solving for we're gonna change this problem. We're gonna say x minus 2 over x minus 1 over x minus 3 x minus 4 squared equals 0. We're gonna solve for it now. This is just a fraction, right? So what makes this nice is I can cross multiply, can't I? And what gets eliminated when I cross multiply? The denominator. So my new equation when I cross multiply, because I'm going to take that denominator times 0, right, is going to give me x minus 2 times x minus 1 equals 0. Right? Because this times 0 is just going to disappear. Are you with me? When I take this and cross multiply, it just goes away. So really, in a fraction, when you're trying to find your zeros, you're really looking at the numerator. If you have a single fraction, not like what we have over here, where we're adding fractions. Okay, that's a little different. All right, this tells me that x is equal to 2, and, okay, these create more intervals for us, 1 and 2. Now, this was an open interval, so at 1 and at 2, I put open intervals there. Because I have to have values less than 0. I can never have values that will give me 0.
So why did you factor in 4?
Because those are the values that x can't equal, because those created undefined fractions. I am not allowed. I might get a negative value with those. I might also get 0. Okay, all right, so now here's our problem. we set up our intervals about what x can and cannot be. That's this step right here. Okay? So use the test points to figure out where we're going to find answers that will work. Okay, I'm going to make this bigger because this is kind of small. So our intervals are at what? 1, 2, 3, 4. I have to test a value here, somewhere to the left. I have to test values in between 1 and 2. I have to test values in between 2 and 3, in between 3 and 4, and to the right of 4. So I have to find values 1, 2, 3, 4, 5 places, 5 values to test. It gets tedious, okay, because this has so many intervals. So we just start, and we are very methodical about this. What is a great value to use to the left of 1? Perfect. So let x equal 0, and we plug it in to our original inequality. So if I plug in 0, I get negative 2 times negative 1 over negative 3 times negative 4 squared. Now, what makes this problem really nice is overall, remember, because it was less than 0, I'm just looking for what kind of an answer? A negative. So who cares what the number is at this point? Let's just see, do we get a positive answer or a negative answer? Well, I know a negative times a negative is a, and over here I'm going to get a negative, and what is this one going to be? And what is my overall denominator? So therefore, what is my answer? Isn't that a negative answer? What kind of answer do I want? So I want values to the left of 1 because they give me negative values, right? So part of my graph is going to look like this. Starting at 1, going to the left, those numbers are going to satisfy that inequality. Yeah, I'm just doing a number line answer, and then I'll come up with my inequality. Okay, now, what is a number that falls between 1 and 2? Sure, you know. So let's plug it in. If I plug in 1.5, I get negative 0.5, positive 0.5, negative 1.5, and who cares about this next one? Because what is this next one always going to be? Because I'm squaring it, right? So who cares what it is? Because remember, in this problem, all I'm worried about is whether my answer is negative or positive. Y'all with me? Okay, so what is my numerator going to be? What is my denominator going to be? Do I want this interval? Because it gives me what kind of an answer? So I don't want anything in here.
Once you know that you got anything between 1 and 2, do you even have to test like above 2? Or?
Of course, because I have another interval. I have another interval between 2 and 3, and that one might work. Just the interval between 1 and 2 didn't work. It doesn't imply that everything to the right of 1 doesn't work.
Why are you stopping at less than 0? And why are you doing the intervals to the left of 1?
Because I can get negative values. Because of the way this is set up, I can get negative values depending on the numbers that I use. Okay? All right, so now we try between 2 and 3. What are we going to let x equal? Okay? So I'm just going to go now, and I'm going to go negative, positive, okay? I'm not going to worry about what that value is. If I plug in 2.5 into my first parentheses, do I get a positive or a negative? And if I put it in my second one, positive or negative? Positive. Be careful. If I put it in my first one in my denominator, negative or positive? And this last one is always, so what's my overall answer, positive or negative? All right, I want that one. That means I'm going to take all my values between 2 and 3. It's going to work. Correct? Okay. Now let's do, what's another value I have to use? All right, if I put it in my first one, do I get a positive or negative? What about the next one? What about down here, first one? Which one is it, positive or negative? Yeah, and the last one is always positive, therefore this is positive. Do I want this interval? Okay. All right, last one that I'm going to try is x is equal to, sure. I wouldn't use 4.5, although I could. What is my first parenthesis going to be? And my second? And my first one down here? And this one's always, therefore, do I want anything to the right of 4? So my interval then falls, but x is going to be less than 1. And what's my next interval? Isn't it just between 2 and 3? Right? Allie? Mm-hmm. Now recognize that this one is just, right, 0. I'm not always going to have 0 here. So there are some times if I have a number that I have to compare to that value and I have to physically work it out. Do you understand what I'm saying? Like let's say the 0 was 5. Then I'm trying to compare during my intervals, when do I get values that are less than 5. But when it's less than 0, it makes it very easy because you're just worried about positive or negativeness of your answer. Yeah, we can. Mm-hmm. Yeah. And x is between 2 and 3. Mm-hmm. This is my final answer right here. All right. Let's try the next one. Do I have one that doesn't have? Let's do this one. We'll do the U try here because that has a value other than 1 in it. Okay? I mean 0. Okay? What can t not equal? Just can't equal 0, right? Would you agree? And then, obviously, in this case, I'm looking to solve, so I'm going to really rewrite this now. And how would I go about solving? So what would my common denominator be? Well, their answer's in here somewhere. Someone has said it. 4t. Why? So if I look at 1/2 and 1/4, what's my common denominator? 4. If I look at 1 over t and 1 over t, what's my common denominator? So wouldn't you say then 4t is my common denominator? So I multiply this by 4t. When I take it to this first fraction, what do I get? When I take it to the next fraction, what do I get? And when I take it to my end, I get 4t. Oh, I wrote, I'm sorry, that's my fault. So it's 3, yeah. I just wrote a 1 there, Abby. So I get 5 is equal to 4t. So when I solve this, t is equal to 5/4. So my interval now has just 0 and 5/4, which in our mind we know is 1.25. Correct? And because x cannot equal 0, we know that this is open. Right? And because our inequality initially is strictly greater than, the value that we get when we solve must be, okay, open or closed? Open or closed? Therefore, it's open. If I had an equality here, I'd be shading this value in. Do you understand the difference? Okay. All right. So, it has to be greater than 1 now. Not positive or negative, greater than 1. So values that we will try, let t equal what? To the left? -1. Okay? To the left of 0. So when t is -1, I get 1 over -2 plus 3 over -4. Is that greater than 1? That's the question you're asking yourself. Well, it's going to be -5/4. Is that greater than 1? Don't want that interval. But do you see how we're comparing it to 1 now, not 0? Not is it positive or negative? Y'all with me on this? Okay, what's another value that I'm going to try then? Sure, let t equal 1. Okay. At 1, I get 1 over 2 plus 3 over 4. Is that greater than 1? Okay, that's a good one. I want that interval. What's another value for t? I would refrain from using decimals, so I could use 2, I could use 3, I could use 10, right? So 2. This gives me 1/4 plus 3/8. Is that greater than 1? It's 5/8, isn't it? 2/8 plus 3/8 is 5/8. Is that greater than 1? So I want the values here. How do I write that inequality? That's the only interval that's going to work in this problem. That's going to make that. Isn't x greater than 0 and less than 5? She said 0 less than x less than 5/4. I thought. That's what I heard. Okay? How we doing? Okay? All right. Let's go on to 4.7. It says day 1 and day 2, but we're just going to. Where do I start? Here we go. Okay. Isolate the root, remove the root, solve for 0. And this one, you did this last year. You always must check with square roots. Square roots are funny. You do not have to check cubic roots, but you do have to check square roots. You did this last year. Okay? So isolate the root. If I'm going to isolate the root, what has to move? So that means x minus 3 equals square root of x minus 3. How do I remove the root? What do? I'm squaring the side. So I square the other side. What does that give me on the left? It is not x squared minus 9, right? It's a product of x minus 3 and x minus 3. This is a Mrs. Dunn problem on the left side. So yes, x squared minus 6x plus 9. Okay? Solve for the 0. That just means solve. X squared minus 7x plus 12 equals 0. X minus 4, x minus 3 gives me 4 and 3. What's that last step say? And how do I check? Where? In the very first step before I did any kind of manipulating. So I need to check. Does 4 equal the square root of 4 minus 3 plus 3? Does 4 equal the square root of 1, which is 1 plus 3? It does. So 4 is a root. We check the next one. Does 3 equal the square root of 3 minus 3 plus 3, which is 0? Does 3 equal 3? Okay, therefore these are both solutions. If you get a no on your check, then that value is not a solution. If you do not show me your check, I will not give you full credit. The only way you are guaranteed to get these problems right is to show me the check. Okay? Remember doing this last year? Okay. I'm going to skip this one because this one's an easy one. I'm going to go to a different one. Oops, what happened here? Uh-oh. Okay, this is the one that I want to go to right here. Yeah, kind of far down. Okay, what makes this one ugly? Okay, so if there are 2 square roots, you put them on opposite sides of the equal sign. There's no way to isolate it. No way. Okay? And then we go through the process again. Square this side, square that side. Nope, you square the side. You square the side. And this is one you really need to pay attention to. Yeah, you do. What does that give me on the left? That's pretty. But on the right side, it is helpful in this case to really show this. You're foiling. You're going to get 1. How many of these are there going to be? Aren't there going to be 2 of them? And then what is this times itself going to be? 2x minus 12, right? You following the math? 1 times 1 is 1. Root 2x minus 12 and root 2x minus 12 means I've got 2 of them. Root 2x minus 12 times root 2x minus 12 is just 2x minus 12 because the roots cancel. All right, so we go through this process again. We have to isolate the root. So that means everything comes to the left but the root. So the 1's will cancel. I'll get a negative x on the left and a negative 12. Would you agree? Thank you, positive 12. And that's going to equal 2 root 2x minus 12. Now, if this 2, which you should technically get rid of by dividing, doesn't come out evenly on the left side, in other words, I'll get a negative 1/2. Do you see that on my x? Leave it on the right so that you don't have to deal with fractions. And we go through the process again. What do we need to do? Square the side. To square the side, be careful on this right side. I'm going to have a 4 here because a 2 squared is 4. But then I get 2x minus 12 because what's under the root is just what's under the root when you square it.
I missed that before. It says like 2x squared, 2x minus 12. Is that because there's 2 roots?
Well, I'm going to get 1 times square root of 2x minus 12. And then I'm going to get another 1 times the square root of 2x minus 12. So it's like saying a plus a. Isn't that 2a? All right, on the left side, I'm going to get x squared minus 24x plus 144. And over here, I'm going to get 8x minus 48. And so that's going to give me x squared minus 32x plus 192. My math right? Yeah. That's oops, that's supposed to be a 9. It started out as a 5, I think.
96.
Yeah, see? No, I don't think so. 144 and 48. I know I'm going to have a 2, 192. And so what would I need to do at this point? Factor, maybe use the quadratic formula. Okay. What's the problem? And so my answers are, just so we know, 24 and 8. Using the quadratic formula, you're going to get 24 and 8. I'm just jumping because we're losing time here. And what do I need to do? Check it. I have to check. Cubic roots don't need to be checked because you can have negative values under that cubic root. But square roots have to be checked. And so I'm going to go the square root of 25. Does that equal 1 plus the square root of 50 minus 12? Well, 24 plus 1 is the square root of 25, right? Does that equal 1? And then, oh, that's 48, sorry. What's 48 minus 12? So what is this is 1 plus 6. Does that equal 5? Therefore, 24 doesn't work. And when I plug in 8, I'm going to get, hold on, the square root of 9. Does that equal 1 plus the square root of 18 minus 16 minus 12? Does 3 equal 1 plus 2? So 8 is the one that works. They're not. And some of them, none of them, sometimes none of them will work. No, we're checking because there will be times when a solution won't work. I'm not just trying to make your life hard.